people. This is for lesson 1.4. First thing I'd like to do as we start off into this is go through a couple of key concepts. So starting up at the top, our first key concept, we have seen and been able to measure a steady trend that has shown us that um, we have increasing temperatures. And that's been happening since 1880. We've we've also had increasing ice as a result of that. And really, to break that concept down a little more scientifically, we would say that the average temperature increases when energy absorbed by the surface increases. So again, we're talking about energy being absorbed or being taken in, similar to our light waves unit. Now, this right here, this is really important for you guys to kind of commit to memory. And really, there's two gases that are key contributors to climate change: carbon dioxide and methane. And when the amount of either one of these two, carbon dioxide or methane, increases, the amount of energy that's being absorbed by the surface increases. See, the surface of the Earth radiates energy out, okay? Just like your body's doing, just like the table I'm sitting at is doing. But imagine the Earth, it can radiate a lot of energy out of it. However, if we have methane or carbon dioxide in our atmosphere, what can happen is when that energy starts to exit the Earth's system, it can hit those gases, and those gases will bounce that energy and reflect it right back down to the Earth's surface, increasing the temperature. The exact opposite thing happens when we have a decrease. We have less of those particles, so we can have more energy exiting the Earth's system than is being absorbed. And we'll see that again in another key concept. So a change into either the amount of energy entering or exiting the system affects how much energy is being absorbed by the surface. In other words, affects our temperature. And we can see that here. As temperature increases, temperature increases when more energy is coming into the system than is going out. And the exact opposite is true. Temperature decreases if there is less energy coming in than is exiting the system. So, this lesson, friends, has 5 parts to it. Warm up. Part 2 we're basically going to skip. Part 3 is a sim, and then we have a writing prompt, and then an article to read. So let's break all that down for you. So one of the key things we're going to be looking at here is what kinds of changes to the atmosphere could affect how much energy is absorbed on the Earth's surface. First things first, let's answer this warm-up question here, which is focused on the atmosphere. What is the atmosphere made of? Do your best to just answer that question with whatever knowledge you're coming to the lesson with, and we're going to answer it here in a second. So let's go ahead and pause that video, answer that, and then we'll move on. So here's our vocab word, or one of them, atmosphere, and it's a mixture of gases surrounding the planet. And our planet's composed of nitrogen, oxygen, carbon dioxide, methane, sulfur dioxide, lots of different gases. I pretty much said those in order of how much we have there in our system. Again, we're just going to skip part 2, but we're really focusing on the sim is why is the ice on the Earth's surface melting. When we get to the sim here, you're going to want to click here to open up your sim. And then let's go back and look at these instructions. So this is designed for you to work with a partner. You're going to do all the tests yourself, but that's okay. It really won't take you very long at all. So let the sim run. So you're going to open up the sim. You're going to let it run. You're going to push play. And you're going to keep it going. Here's your timer over here on the left. And we're going to let that go to 20. And then it says make only one change per test. When increasing, set the gas at 500 parts per million. When decreasing, set it to 0. Run the test until it reaches 40. Observe the temperature, amount of ice, and uh, the glow of absorbed energy. There's a graph there. You want to take a look at the graph and look at the temperature, surface ice energy absorbed, and record your results down here. So it looks like we're gonna do nitrogen dioxide first, and when we increase it, the directions told us to crank it up to 500. So my sim's at 14 seconds. So here's my nitrogen dioxide, and I'm gonna crank that up to 500. And I'm gonna turn it on so I can see those particles. And we're gonna run this to 40. We can observe the ice if we have any rapid changes here. So I'm going to pause that. I'm going to pull up the graph, and we should see we've got our temperature. It kind of went up a little tiny bit, but it stayed pretty steady. The surface ice held steady, and the energy absorbed, there were fluctuations, but it held relatively steady. So now that we have that data, when I increase nitrogen dioxide, energy absorbed by the surface did not change. Temperature did not change. The amount of ice did not change. Okay, so now I need to just go and reset. Reset. And start the sim again. Let it get to 20, and I'm going to speed it up. And we're at 20 seconds. So now I'm going to decrease. So I'm going to take nitrogen dioxide all the way down, push play, let it go another, let that get to 40, and I'm going to make it go really fast now. Boom. So I'm hit pretty close to 40. Okay, seeing a lot of the same things. So the ice stayed about the same, temperature stayed about the same, and the energy absorbed, there's fluctuations, but it stayed about the same. So now we know when you decrease the nitrogen dioxide, did not change, did not change, did not change. Now we're going to continue on testing carbon dioxide, and I also want to point out that for this page 2 here, part 3, we're going to move on to sulfur dioxide, and we're going to move on to methane. So what I'd like you friends to do is do the rest of those sims on your own. Again, if you missed how I did that, just pause the video, rewind. The same thing I did with nitrogen dioxide, you'll want to do with carbon dioxide, sulfur dioxide, and methane. When you get to part 3, this is when you're all the way done, you need to choose your side. Are you going to agree or disagree with the claim? All I want you to do is agree or disagree. You can skip the screenshots. Okay, now for this part, this is where, again, we would do some sharing with a partner. I'm going to leave it to you on your own. You have a word bank here, and you can use your key concepts, the stuff that we just did in the sim, but you're just going to write at least 2 sentences using some of these words up here to answer the investigation question. And again, that question is, what kinds of changes to the atmosphere could affect how much energy is absorbed by the Earth's surface? Pause that video, and then we'll go over to the homework section. All right, peeps, this is the end of the lesson. This is a really fascinating story. It actually all took place when I was a kid, when I was about your age. Yeah, we created a hole in the ozone layer, we nasty humans, and it's because of some chemicals we were using, chlorofluorocarbons, which are no longer used, but we actually put a hole in the ozone layer, and that's part of the reason why, as we learned in Lightwave's unit, why Australia has so many incidences of cancer, skin cancer. So friends, read this article, answer the question at the bottom, right? And then push the hand in button, and then you are done. Don't forget to like, share, comment, subscribe. Thanks for being here, and I'll see you next time.